So, the diagram shows the velocity time graph for a particle moving at v meters per second in a straight line, t seconds, so t is on this axis here, after passing through a fixed point. The particle travels at u meters per second for 20 seconds and then decelerates uniformly, so that's along this section here, for 10 seconds down to a velocity of u over 2. In the 30-second interval, the particle travels 165 meters. Find the value of u. Well, the distance would be the area under this graph. So the rectangle has an area of 20u, and then we could do this as a trapezium, or we could do it as a triangle and another rectangle. Let's do it as another rectangle. So that's going to be 10 u over 2 for the area of this rectangle just here. And then we'll have a half times 10 times the height of that would be u over 2 as well, wouldn't it? So, and all of that must be equal to 165. So I've got 20u, add 5u, and then here we've got a half of 10 and then a half again, so that's going to be 2.5u, and that's equal to 165. So altogether that's 27.5u is equal to 165. So 165 divided by 27.5 gives me 6. So u is 6 meters per second. So now we want to find the acceleration of the particle between t equals 10 and t equals 30. So that's going to be the gradient of this line here. And we now know that this is 6 and therefore this is 3. So this goes down 3 and across by 10. So the acceleration is just that gradient. So it's going to be negative 3 over 10, or negative 0.3 meters per second squared. Okay, so we're on to a second part of the question now. So a particle travels in a straight line such that t seconds after passing through a fixed point O, its velocity is given by this expression here. Find the speed of p at O. Well, at O, that means that t is equal to 0. So v is going to be e to the 0 take away 4 cubed, or at least that will be the velocity, which is negative 3 cubed, which is negative 3 cubed, which is negative 27. So the speed is going to be 27 meters per second. Find the value of t for which p is instantaneously at rest. So rest means that v is equal to 0. The only way that can be 0 is for the inside of the bracket here to be 0. So we've got e to the t squared over 8 take away 4 is equal to 0. So that would mean that e to the t squared over 8 is equal to 4. So we could take the natural log of both sides there. So we've got ln e to the t squared over 8 is equal to ln 4. So that would be t squared over 8 ln e is equal to ln 4. Ln e is just 1, so t squared over 8 equals ln 4. So t squared is going to be 8 ln 4. So 8 ln 4, 8 times ln 4. So the final part of the question is find the acceleration of p when t is 1. So we need this expression here. So v is equal to e to the t squared over 8 take away 4 cubed. For acceleration we need to differentiate that. So the outside function is the cube, so we've got 3 e to the t squared over 8 take away 4 squared. But remember the chain rule, we now need to multiply by the differential of the inside. So the 4 would disappear, and then we'd have e to the t squared over 8. Let's check that is t squared, isn't it? Yep, t squared over 8. And that's got an inside function as well, which is, if we differentiate that, we get 2t over 8. So obviously we can cancel that down to a 4 on the bottom there. So we're going to have 3t over 4 e to the t squared over 8 e to the t squared over 8 take away 4 squared. And we want that when t is 1. So that's going to be 3/4 of e to the 1/8 e to the 1/8 take away 4 squared. And we just need to calculate that. So we'll have 3 over 4 multiplied by e to the power 1/8 multiplied by e to the power 1/8 over 8 take away 4